Okay, compiler time. Okay, so last we left off, I was doing the lowering into IR, and I had found a bug where the jump into labels was wrong. The X value of our loop was incorrect. I had if I go back, was in test 4? Yeah, I had this function here that I was trying to compile. And here in the while loop, we modify the X that is used for the condition. Therefore, the register in which it is assigned should be given as an argument to label 5 the loop condition, and it wasn't. And I briefly looked at the code after the stream, and I think I know what the bug is. I have two functions with the same type but different names, and I think I'm calling the wrong one. Because I have a seal block thing that does the seal of the label, which is the same argument there, but also properly closes the block. There again, I am using this research paper as my inspiration. Simple and inefficient construction of static single assignment form. The difference being I make one improvement on it, which is I'm no longer using phi functions, I'm using block arguments. And when I encounter a block whose parents are not all known, I have to use placeholders that I need to then register as block arguments at the end. And I think I have a few places where I call seal instead of calling seal block. Like here, for instance, on an if statement, which I think is fine. I think calling seal and not seal block is fine on every single thing that doesn't have. But I think I might as well do a seal block everywhere. Because I think it's gonna make no difference for most of them, but will be correct for the few that have like a loop condition or something. Okay, so let's try that. I see two variables in label 5, which makes me happy, but I still only see one. I don't see one in label 7, which makes me worried. I think this is wrong. Okay. But still seeing two there is pretty good. So let's go back to this. So our function starts with two arguments, which are in the registers I0 and I1, because it's two int values. We do assign 0 to the register I2, and then we compare for equality I0 and I2, and we store the result in the boolean 3, which is the new register. We do a branch based on that boolean register. If it's true, we jump to the label 3 with the values B3, I1, I0. Interesting that they're in this order. Otherwise, we jump, which is at the end of. If it's true, this is an OR, so that's we jumped immediately out of the thing, which is label 3. But if we have false, then we need to evaluate the right-hand side, so we jump to label 2. In label 2, which is the right-hand side of our if, there again, we are reading. Oh, that's because it has only one parent. Since it has only one parent, there's only one place that jumps from to label 2. Then the variables here is the register there is necessarily defined by that point. Okay. So I think this is therefore fine for this then, probably. So since we are falling from label 0 where I1 is defined, we know I1 is defined. Is that correct? Yes, that looks fine. This is not... Okay, so that should be fine. At least this is consistent with the research paper, at least. Okay, so here in label 2, we're only jumping from label 0, therefore there's only one parent, therefore it doesn't need to give any block arguments. The things will be accessible from before, so I1 is accessible. So we assign 0 to the register I4, we compare the second argument of the function with 0, and we store the result in boolean 5. And then we jump to label 3, the outside of our if, with b5, which is the result of our comparison, and I1, I0. So here, this branch, it has two parents, but here I could probably do some simplification and realize that I15 and I16 are always initialized to I1, I0, and therefore they are not needed as arguments. Okay. That is correct, at least. And this, at the end of the OR, is our if, and we do immediately a branch on the Boolean result of the OR, and we jump to label 4 if it's false, and we jump to label 1 if it's true. And if it's true, no, sorry, it's true, it's label 4, 1 is false. So 4 would be, if it's true, we assign 0 to a register I7, and we return from the function with I7, okay? Otherwise, we jump to label 1, which is immediately a jump with I15, I16, which are I0, I1, okay? Which are the original values of y and x, respectively. So here they're named I11 and I8. We assign 0 to I9. We compare greater than A8 to I9, which is comparing x greater than 0. If it's true, we jump to label 6, which is our loop condition. If it's false, we jump to 7, and we are using I11, which is the latest known value of y, which is correct. And here we add to a new register I12, I11, which is the y value, and x, I8, yep, there we go. And then we assign I13 to 1. We subtract into I14, I8, so x minus 1. Yeah, okay. And we jump back with I12 for the new y value, which is the new register. Okay, that's fine. And I14, yeah, okay, that looks good. So the only thing is, we could probably detect that both parents are using the same value. That's something we could do. So when I do a register block argument, this is where I could be smart and then look at first So here I could check first that the parents would give different values to the Okay, so what I could do is create a hash map of parents to, so parents, that would be in the monad. Okay, for a label, it gives me a list of labels, so this is a list. So what I could do is, this thing is monadic, okay? So I should do, so the map from parent to the source map, if you will, would be for each of the parents would be this thing. Okay. And now I can check if I get the LMs of the source map, and that gives me a list of values, and I do a nub of them. I just resolve name in. Let me check what it gives me. It gives me a register, and a register is an int and a type, and I could probably do, so I don't want to do a nub there. I want just to check the index is the same. Okay. There we go, here. So here I want to check that whether all of the values are the same, but I don't have equality on registers. So I just want to check when not all same LMs of the source map. And here is where I would do this. I would append the argument. Oh, wait, no, doesn't work. That doesn't work. It's too late at this point. It's too late at this point. This is the point where I would need to then, because I'm saying, okay, I don't need to make this register an argument of the block because all of its parents will call it with the same value anyway. But if I were to do that, I would need to also change all of the code of the block to rename. Okay, so I'm not gonna bother. I'm not gonna bother. It's fine, I think, to just keep the code as it is. Oops. Okay. Let's try something else. We've tried an if a while. What if I were to try something a bit more complicated? Let's try let x equal 0 while x is greater than 0 if x modulo 2 equals 1 return 4 or something. It doesn't matter. And x minus equal 1 return 0, whatever, it doesn't matter. What I want to test is there is now no longer one block for the loop of the body of the while, now we have several blocks there, which means the last block here jumps back to the condition. It's going to be a bit tricky. Oh, except it's named foo as well. It can't. Let's name it bar. Oh, and none of those does a... Let's do a function call. Let's see how function calls work, if they do. Okay, so bar, we start at the label 0. That has no argument because the function has no argument. We assign 0 to I0, the first register. We jump to the loop condition block, which is label 1, with I1 the argument, the new register to which is the argument of the condition block. We assign 0 to I2. We compare greater than, and we saw the result in B3 and I1 and I2. And this is true if I1 is greater than I2. And we branch based on B3, this Boolean. If it is true, we jump to the label 2, which is the start of our loop. Otherwise, we jump to label 3, which is the end of our loop. The end of our loop is assigning 0 to I11 and returning that register. Okay. And the loop here, we assign 2 to I4. Okay. We do a modulo and we store in I5 between I1 and I4. Okay. We assign 1 to I6. We put in the register B7 the value of comparing for equality I5 and I6. So we're comparing I1, which is the X that we're coming from here, to modulo 2 equals to 1. If it's true, we jump to 5. Otherwise, we jump to 4. 4 is the end of our loop. We assign 1 to I9. We subtract into I10, I1, I9, so x minus 1. And we jump back to the label 1, which is our loop, with a new value of x, which is this new I10. That sounds good. And 5 would be the return. So we invoke the name of a function, so it's going to be linked. This is not a function that is in a variable. It is one that has a unique name that we can link against. We store the result in I8, a register of int. This is the function main foo with parameters I1 and I1, because I1 is the one we're currently coming from. Label 5, we only jump to 5 from this branch, label 2. We only jump from label 1, so it is indeed the value I1 there. Okay, that looks good. So now we should have most of the lowering into AR. Whew. Which means we should be able to start writing some of the... We should be able to start writing some of the code generation at this point. I didn't expect to have time to work on the compiler this evening. I thought it would take more time to do all of the advent of code. So I am not sure how to make progress there. I suppose I could, because there's two things I want to do there. I'd like to really also do something that exports this IR into LLVM IR, which would be very nice to confirm that one, our thing is more or less correct, and two, that we can try to compile actual programs already. That would be nice. I need to figure out a way to represent built-in functions, because at some point when I want to actually test code, I will need some kind of print that I don't have yet. And how that connects to the LLVM IR as well. And I suppose I will need to start thinking about the code generation, how we translate the series of blocks and labels and registers into the bytecode, where a function will be a list of instructions. I suppose this is also gonna need something else. I'm gonna need. I think I'm not gonna do more work on the compiler this evening just because I need to think about this. I'm gonna also need register allocation, which register allocation tends to be it's gonna be a bit simpler in our case because register allocation tends to be very smart and like maximize CPU registers and only go to the stack for from when you have no register free anymore. We have no registers. All of our virtual IR registers will go on the stack anyway. The only question is, can I do this register allocation ahead of time and I transform the IR into a transform version in which the registers have like a new type that reflects where they are on the stack? Or do I do this as part of the code generation as just one big phase? I think I'm gonna do the latter, but I think I need to think about it ahead of time. So I think I'm gonna think for tomorrow what I want to do next for the project. Whether I do the exports to the LLVM IR or whether I start doing the code generation. Like, what do I work on next? And start planning this. And yeah, I think that's gonna be it for this evening. Finish early for once. So I'll see you all tomorrow evening for day 9 of the Advent of Code. Hopefully, I cannot run a Fibonacci yet. I'm close, but not yet, because as you can see from a function like this, we can go all the way to like lexing, parsing, analysis, which is like name resolving, type checking, and so on, all the way to the lowering into IR, where we have this pseudo assembly with like labels and jumps and basic things like that, which is basically purely putting things on the on virtual registers, performing basic operations that put the result in new registers, and doing a jump or branch based on that, which is more or less the format of the LLVMIR. And the only thing that's missing is to translate this thing, this IR, into a series of bytecode, which is the actual Pete instructions. And here, this would be basically, we would start with like push a number 0 and then do a greater or something like this. Oh, wait, no, we do a jump to this one. So this would probably, yeah, this would be put as a push an address and then jump to that address. So push address and then return. And then we would have an entrance. We would have an entrance. Well, the thing is, past the backend, when we do generate this, the rest is done. So when I have for each function a list of instruction like this, which is going to be like an entrance for each block, a bunch of like push values, push addresses, greater duplicate, all of that stuff that does manipulate the stack. When I have that, the rest is done, because what's left is the linker, where basically, okay, each function makes a reference to an address, which would be in a given unique function that has a unique symbol name, one of the blocks within. And we need to assign a unique integer address to each and every single address in every single function for function calls, for jump within the functions, and so on. That's the linking phase. That's done. It transforms this thing where before that, we no longer have entrance addresses. It's no longer required. and push address has been transformed into a push int. The linker is done. And then when we have for each function a list of instructions where we no longer have addresses, we have ints everywhere because we have assigned a unique address to int address to everything. Doing the assembly of generating an image based on the functions, that part is already done. This is how we got this program. That part is already done. That is just so that program was generated by having a list of we're going to function bar at address 0, and like I don't remember exactly what it was, but this was we write two functions that like know about one another. So we do the linking so that each entrance into a block, like label 0 here, label 0 here, label 1 here, is assigned a unique integer address. Then we have the linked version and then assembling the image. All of that is already done. So getting from IR to instructions, it is mostly straightforward, except for one thing, which is the registry allocation. And that is basically when I do my lowering into IR, I am doing the same thing that the LLVM IR does, which is like assign like this is a single static assignment or static single assignment, and I remember which order it is. It is a static single assignment, yes. So each register only appears once. Like here, I display them with like a thing that indicates the type, but it's basically register 0, register 1, register 2, register 3, and so on. And they're only ever assigned once. But the thing I need to do next is basically decide where do those go on the stack. I know that the start of my function, the arguments to label 0, are what is on the top of the stack when I start in the function, but I need to then figure out from each block, okay, I'm going from this shape of the stack to this shape of the stack. How do I make sure that, like, how do I assign my registers on the stack so that the order of the registers is consistent and that when I return from my function, the stack is in the shape that I expect? That part is the difficult part. But getting from IR to instructions, once I figured out the registry assignment, yes, that is pretty straightforward because most of my operations in the IR have a corresponding bytecode thing. So, kinda, yes. Kinda. The only thing is, again, registry allocation is a standard compiler thing, but ours is going to be a bit different and probably a bit simpler because usually registry allocation tries to maximize the stuff we put in the actual like CPU registers and only push to the stack when there's absolutely no more room for operations. We're gonna all go all to the stack because we have no other option. But that is gonna be the tricky part. One thing I'm gonna need to figure out, for instance, is here when I jump to label 3, I need to have the shape of my stack be those 3 values in that order if I want to. So I will have to introduce like some swaps and some other operations. But here, when I jump to label 2, I have no restriction on the shape of the stack. What does that mean? How do I guarantee that my function actually like ends up in a shape where the stack is, is in the correct shape? That is gonna be tricky, I think. So I'll need to figure that out. I'll need to figure out a way to do registry allocation, and I need to think about this. And I'm not gonna think about it on stream. I'm gonna think about it off stream, I think. But I think this is the big next task. So I think the 3 big next tasks would be 1, doing the export from this to the LLVM IR so we can try to use the LLVM backend and try to see whether that works and provide a reference. The second thing would be to do the same thing that some of the compilers, I think including Rust compilers, do, which is to export this as a dot file that shows the graph of the different instructions and shows the control flow, basically, which would be very nice to have like an export of this into a control flow graph for debugging purposes. Potentially also reuse our pretty printer to make complete this page that currently shows us the past version, the validated version with like all the references and everything, and maybe add a third version, which is the SVG of the dot graph of this, basically. And of course, third and definitely not least, last but not least, would be starting to work on the code generation and the registry allocation. I don't know yet which one I'll work on next. It will depend on, again, how much time I have this week with the advent of code, and how much time I've had to think about how I want to approach this next. In the meantime, I'm gonna stop here. I'm gonna go get some sleep, and I'll see you all tomorrow evening for more Advent of Code and perhaps some more compiler. Oh, I should look something. Okay, I haven't done that yet. I should look at the people who have raided me in the past and see if they are actually streaming so that I can actually raid. I've never used raids before, but I feel like I need to return the favor. I'll have a look at how that works. Oh, also, I need to do. I haven't uploaded yet any of the streams that contains like Advent of Code and compiler work because I need to split it and upload it on the channel in two different playlists. The YouTube editing video thing is dog shit, so I'm gonna have to do it manually on my end. I'll try to do that this week. Okay. Thank you, everyone, and I'll see you tomorrow.